Hi, hello everyone. So this is our topic for video part B, which is functions in C++, but where the parameters are being passed by reference. Okay, so again, you be sure to read the information on the PDF file posted on Blackboard first before you watch the video, because this is going to be a summary rather than a thorough explanation as the PDF. Okay, so when we pass a parameter by reference, we're not passing a copy of the parameter, we're passing the actual parameter. So once the function finishes, if you made a change to the parameter being passed, that change will be carried back to the caller, which in this case is our main program. Okay, so I'm going to again show you the idea of passing by reference with two examples, and maybe three. Okay, so the first thing we want to do is we want to create a function to double the value of a number. Okay, so for example, if the user passes the value 3, I want the parameter, the actual variable, to change to 6. If the parameter is 3.5, then I want the result variable to be 7, and so on and so forth. Okay, but I want them not return anything. So this function or these functions are going to be void functions that are going to make the change on the variable itself. Okay, so let's do this. So I need a function that is going to double the value. I can't call it double because this is a variable type in C++, so I'm going to call it double v for value or val. So this is going to be my function name. I'm going to pass n, and remember this is the function call. There is no return type, so you're not going to do equals some number here. Yeah, we're not going to do that. Okay, and afterwards, I just want to say the original value was, oops, needed to put the quotes right here. The original value was, and the new value is. I'm gonna call the function double value. Now I can't call it before. And now I can say n. Okay, so let me create the variable n, which is double is okay, but it could be an integer. Right? So maybe I'm gonna make it an integer, but this is easily changed to a double. So I create a variable n. The user, I need to input value from the user first. So I'm gonna say enter n. And notice I want a space here, but if you don't want a space, that's fine. I want it to be as easy as possible in the eye. So I collect n, I print out this message, I call the function that is going to double my value. Notice there is no return, and then I print that value. Okay, so this is my function call. And now I am going to write the function definition. Now it's void because the function is not returning anything. So double v, I'm going to receive an integer n. All this function is doing is doubling it, the original value n. Yes? All right, so that's all I want to do. Okay, but I need the prototype. So the prototype, remember, just copy the first line of the function definition. This is the definition. Let me just write it here. You saw it in the other video, but it's just to clarify. So for the prototype, which needs to be above main, just copy. This is the prototype. Copy the first line of the function definition and then add a semicolon. All right, so I'm going to save. I am going to build. And there is a mistake. There's an error on line 29. Let's take a look at line 29. And here's line 29 is the return statement. What's the problem? Well, if you read the information, you said the function is void. So what is it that you're returning? You cannot return. This doesn't work. So how do I change n if I cannot return anything? Well, you're going to do this. N times 2. You can either do it this way, or you can use the more sophisticated operand, which is multiply n by 2 and put it back into n. Okay, so this is fine. If you don't like it, that's okay. You should be familiar for the exam, but you know, it's fine. Okay, so let's see what happens when I do this. First, save, compile, build. There should be no errors because I have the prototype. Everything is correct in main. The function definition is perfectly fine. Okay, so there should be no problem here. Let me run now. I made a change, so I have to rebuild. Let me run this and let's see what happens. I am going to type a number. It's an integer, so how about 7? I should see 14. So the original value was 7, the new value is 7. So it seems like it didn't work. Why didn't it work? Here's the reason why. Okay, everything is correct except here. When you do this in C++, C++ says and understands that you're passing the parameter n by value. Meaning what? This n is the original value. This n here is a copy of this value. Even though they have the same names, you made a change only on the copy, not the real value. How do I change that? Well, you change that by passing by reference. How do I pass by reference? You put in an ampersand symbol, right? Ampersand symbol. Make sure you change it in the prototype. You don't have to do anything in the function call. Save, build. There should be no errors here. No errors, no warnings. And now when you run this with your number 7 again, we have the correct result. The original value was 7, the new value is 14. Okay? The reason for that is you pass the original value 7, and here, because of the ampersand, you're receiving the actual parameter or the actual variable from main, not a copy. So when you do this, you made a change in the original variable, not a copy of the variable. And that's why you saw here 14. Okay, so to pass by reference, we need to use the ampersand symbol. Okay, good. Let's make another function. Okay. Pretty much the same as before. And I am going to, in this case, I'm going to have two variables, x and y. These are going to be coordinates in the plane, Cartesian plane. And what I want is I'm going to collect user input, enter X, C out, enter Y, and so the user is going to enter whatever values, and they're going to be coordinates in the Cartesian plane. I am going to create a function that is going to jump. Okay, so jump X and Y. Meaning what? Let's say I want X to go add 5 and Y add 3. So whatever the user enters for X and Y, my jump on the coordinate system will be add 5 to X, add 3 to Y. So there's going to be a new coordinate. And I want to see that after. The new coordinates are, and let's do it this way, be a little bit more sophisticated. Okay, so the jump function is going to receive X and Y entered by the user. It's a void function. I don't want to return anything. I just want to change the values of X and Y. And it's going to do this right here. And then I'm going to print the values to see that they have changed. Okay, so here is my jump function, which again is a void function. A jump is a name I invented. You could call it anything. So int X, int Y, and all I need to do is X equals X plus 5, Y equals Y plus 3. And remember, you need to put the ampersand here, otherwise this is not going to work. And I'm going to show you again that this doesn't work. This is the function definition, and here is the prototype with the semicolon at the end. All right. Now, I don't have the ampersand because I'm going to show you that this doesn't work. All right. I need to pass it by reference. But it's okay. It's just to show you that this doesn't work. So let me compile. There should be no errors, no warnings. Okay, as expected. I'm going to run the code and enter these two values, and then I will see that this doesn't change. Enter X, so -3. And how about 16? So I'm supposed to add, my function is supposed to add 5 to X and 3 to Y. All right, so I should get the new X is 2 and the new Y is 19. Okay, hit enter, and here's my answer, -316. There is no change. The reason for that is because I didn't pass by reference. So I'm going to pass by reference by putting the ampersand in front of the variable and making sure you do the same right here. Okay. Now, when you do that, let's compile and build again to be sure there are no mistakes, When I do that, I am now passing the parameters by reference. So how about 4 and 4? And here x is increased by 5, y is increased by 3, so the function works. All right, so this is to show that you need to pass by reference if you want to change the actual value of the variable. Otherwise, you're going to receive a copy only. All right, so one last one, again dealing with the coordinate system. And again, I want to input x and y. So I'm going to copy this from here. Okay, enter x, enter y. So what I want now is a x reflect. And I'm going to show you what that is. And I'm going to borrow this thing from here also, because it's pretty much the same. Okay, so what I want is this. The person is going to input a coordinate xy, and I want to reflect on, actually this is a y reflect. Maybe let's call it y-axis reflect. This is going to be a reflection on the y-axis. So for example, if the person enters the value 2, 3, the reflection on the y-axis will be negative 2, 3. Okay, it's 2 units to the left of y0. So if the person enters negative 7, 6, the y reflection will be 7, 6. So pretty much nothing happens to the y coordinate, but the x coordinate gets flipped. If it's positive, it becomes negative. If it's negative, it becomes positive. So this is pretty straightforward. Okay, so this is a y-axis reflection. So I am going, again, it's a void function because it's not returning anything. So void y-axis. So on line 40, I have the function call y-axis reflect int x, int y. And this time I am already going to put the ampersand. To be sure the function acts correctly. Now, I don't need to do anything with the y. In fact, this function doesn't even need the y coordinate. I'm going to do it now with the y, and then I'm going to remove it because we don't need it. So I need to change x. So how do I change x? If it's positive, it becomes negative. If it's negative, it becomes positive. All I need to do is multiply by negative 1. All right? If this is positive, it becomes negative. If this is negative times a negative 1, it becomes positive. So this is pretty okay. This is it. That's all I need to do. All right. I need the prototype now. So copy the first line of the definition, go above main, and put a semicolon. Don't have to change anything else. All right. Go back to main. I think this is correct. I don't need to do anything else. Save the code, build all, no warnings, no errors, and I'm going to run this. And let's run it with the values, whatever values we want. Okay, so how about 4 and negative 7? So my reflection will be negative 4, negative 7, correct? Negative 4, negative 7. Perfect. It's a reflection on the y-axis. What if I enter a negative 18? Negative 18. So my reflection would be on the other side of the graph, x will be positive 18, and the y would be the same value. Perfect. Now what if I have x0, 0, y8? Well, it's a reflection on the y-axis, so there is no distance from x to the y-axis, so the new coordinate is still 0, 8. Okay, perfect. So, and this only works because of the ampersand. If you were to remove it, this would not work. So this is how we pass parameters in C++ by reference. When we need the actual parameter to change its value, and when going back to main, have this new value. Okay, so pass by reference means I have to use the ampersand in front of the variable. Now, I told you we don't need this variable y right here, so I can remove it. I'm only using x anyway, and I am going to change here. And obviously, you are going to change in the prototype. If you don't, let's build it now. And the compiler says too few arguments to the function, because the function, the compiler thinks you are passing 2, and here you're only passing 1. So I have to come here to the prototype, change it to 1, save it, build again. There's not going to be any mistakes. I'm going to run one more time, and I'm going to put 91 and 23. And here's the reflection, negative 91, 23. Okay, so this works pretty okay. I don't need to pass 2 because I'm only interested in the x reflection, the y reflection related to the x coordinate. Okay, so this is how you pass parameters by reference.